because some people asked the same or similar questions, I wanted to take a moment to just go over the geometry behind finding the components of mg, the weight, in a ramp problem. Components of mg on a ramp. And because on a ramp, the object in question only has the opportunity to go parallel to the surface of the ramp, we want to find the components of gravity that are parallel and perpendicular to the surface of the ramp. We got mg straight down. I'm going to zoom way in. We've got ostensibly a normal force upward. We might have friction, we might not, but really what we're focusing on here is just the components of mg. I'm going to move this out of the way just a little bit. And first thing we do is just recognize that, or let's give an angle here. Let's just say that this is 30 degrees. So first thing I'm going to do is draw a yellow triangle right here. And recognize that this yellow triangle is a right triangle. So if this angle down here in the bottom right is 30 degrees, and this is a 30-60 90 triangle. So that means this angle right here is 60 degrees. All right. Well, now I'm going to erase that yellow triangle. And now we're going to look at the components of mg. We're going to draw one component this way. We're going to call it mg perpendicular. And we're going to draw this other component here, call it mg parallel. Now I'm going to grab this whole thing, duplicate it, lift it up over here, and I'm going to reorient it just so, you know, the appearance of the triangleness is a little more familiar. We're not used to looking at triangles where it's kind of pointed down in that way. So if it helps, we can think of mg clearly as the hypotenuse, and then mg perpendicular is here and mg parallel is here. But one very important question is, what is this angle? Well, if we recognize that that angle is 60 and this angle here is 90, that tells us that the angle inside, the acute angle inside this triangle is 30 degrees. So this is something we can count on. The angle of elevation of the ramp is also going to be equal to that angle inside there. So that's a certainty, something you can depend on. So at this point, well, from this point, we're really just going to be looking at this triangle, because really what this is all about is what are mg perpendicular and mg parallel. What are these components? mg perpendicular is the component or the piece of gravity that is pulling the object onto the surface. mg parallel, if we were to pick this up and move it up here, mg parallel is the component that is trying to draw the object across the surface, trying to get it to go towards the bottom of the hill. So that's what those each are. Now, let's find expressions for both of them. Whether you look at this version of the triangle or this version of the triangle, doesn't matter. The trigonometry is still the same. mg perpendicular, well, mg perpendicular is the side that is adjacent to the angle. If you think about adjacent and hypotenuse, well, that's cosine. So mg perpendicular is going to be the hypotenuse, mg, times the cosine of theta. And mg parallel, that's the side that's opposite the angle. So if we think about opposite and the hypotenuse, well, that's going to be the sine. So mg parallel is going to be mg sine theta. These are dependable. Put a star next to those. Get very comfortable with those, because anytime there's a ramp, those are going to show up.